Hello, in this video we're going to take a look at some application problems that involve the quotient rule for derivatives. So we have a cost function, c of x equals 3x minus 8 all over 5x plus 7. This function gives the cost in hundreds of dollars of producing x items. Part A is asking us to find the average cost function. The average cost, typically the symbol that we use is c of x with a bar on top of the c. And the formula for finding it is we're going to take that total cost function, c of x, and divide by x. Or that's the same thing as c of x times 1 over x, which is the form we're going to use for this example. So our average cost function is going to be our cost, 3x minus 8 over 5x plus 7 times 1 over x. And we can either leave it like that or we can go ahead and multiply. Remember, when you multiply fractions, you multiply straight across. So we'll get 3x minus 8 in the numerator, and then we'll distribute that x in the denominator and get 5x squared plus 7x. So that would be our average cost function. Part B wants us to find the marginal average cost. And anytime you see the word marginal, that means take the derivative. So we're going to take the derivative of the average cost function. So that's c bar prime of x. We are going to use the quotient rule for this. So we're going to have the bottom 5x squared plus 7x times the derivative of the top. Derivative of 3x minus 8 is 3 minus the top, 3x minus 8 times the derivative of the bottom. The derivative of 5x squared plus 7x is 5 times 2x, or 10x, plus 7, all over that bottom squared. All right, let's go ahead and expand and combine like terms in the numerator. So if you distribute that 3, we get 15x squared plus 21x. And then we want to make sure and subtract this whole second part here. So I'm going to put that in parentheses. And if we multiply this out, we're going to get 30x squared plus 21x minus 80x minus 56. All of that is still over that denominator squared. All right, we need to distribute this negative to everything in that second set that came from that second part of the numerator and combine like terms. We've got 15x squared and negative 30x squared, so that's negative 15x squared. 21x minus 21x plus 80x. Those 21s add to 0, so we're just left with that plus 80x. And then we have plus 56. That finishes up our numerator. In the denominator, we get 5x squared plus 7x quantity squared. And that is giving us the marginal average cost function. All right, let's take a look at another example. Here we have s of t equals 99t squared all over 2t squared plus 11. And this gives the number of items, a new number of items per minute that a new grocery cashier can scan after t hours of on-the-job training. Part A is asking us to find s prime of t. So let's find that derivative. We're going to use the quotient rule here. So s prime of t is going to be the bottom, 2t squared plus 11 times the derivative of the top, 99t squared. When we take the derivative of that, we get 198 times t minus the top, 99t squared times the derivative of the bottom, and the derivative of 2t squared plus 11 is 4t all over that bottom squared. All right, if we go ahead and distribute that 198t, 198t times 2t squared is 396t cubed. 11 times 198t is 2,178t. And then 99t squared times negative, or times 4t, we're subtracting that, so we get minus 396t cubed. And then when we combine like terms in the numerator, those t cubed terms add to 0, and we're left with just 2,178t over 2t squared plus 11 quantity squared. And the units on that, S of t units were in items per minute, and S prime of t is going to be items per minute per hour of training. So this is items per minute per hour of training. That'll help us out with this next part, which wants us to find and interpret S prime of 2. So we're going to just plug in 2 into the answer we just got, 2,178 times 2 over 2 times 2 squared plus 11 quantity squared. And if you plug that in the calculator, you get approximately 12.1. And the units on this are items per minute, the speed of the cashier, per hour of training. So the interpretation of this is, after 2 hours of training, the cashier, this is a positive number, so that means an increase. The cashier is getting faster at a rate of 12.1 items per minute for each hour of training. So that means that if you compare the speed of the cashier after 1 hour of training, they are scanning items, 12 more items per minute than what they were an hour before. So for each hour of training, they are getting faster by 12.1 items per minute. All right, I'll see you guys next time.